Hello, welcome to the Aerospace channel. Today I'm going to talk about the topic of A380 wing cracks and look at the AD timeline between 2012 and today and see the different types of cracks that are known to exist and the airworthiness directives that the EASA has issued on them and see what is the kind of the lessons learned so far on the fatigue cracking of that particular material. So, before we get into the details, here is the quick overview of the A380 wing structure. So, the A380 aircraft is the one of the biggest aircraft, commercial aircraft that is flying today, with the max takeoff weight of 500 ton, more than 500 ton of different variants. And you can see the wingspan there, so almost 80 meters from tip to tip. And the wingspan or the chord you can see is kind of close to 18 meters at the root and about 4 meters at the wing. And the main components that we are going to look at in this video, the cracking of them are the ribs or the rib feet and the spars here, which are kind of there are three types of three different spars that are there in the 380 wing box, which is called the outer front spar, the mid spar, and the outer rear spar. Outer rear spar is obviously the outer one, but I'm just pointing it out the location. So that's the rear spar, that's the front spar, and that's the mid spar. And the front and rear are kind of split into inner, mid, and outer. And because the initial cracking started with the outer ones, so that is the denotion there. And one other component that we are going to cover in this video is the pintle fitting lugs, so which are kind of here. So the A380 structure is kind of quite big in its sense when you compare it with the rest of the fleet of the Airbus produced aircrafts. So here this slide gives a kind of an overview of the size of it. A380, the flaps area itself is equivalent to kind of A320 wing area. So that gives you kind of an idea of how big the aircraft is, and you can see the kind of a comparative view of the different wings. So you could argue that one of the reason for kind of the known cracking on the A380 is maybe some additional loading due to the bigger size of the wing, but more what we understand today is more is linked to the material that is used in those components that have exhibited cracking so far, which we are going to see in the next few slides. So what are the three types of known crackings that we know based on the airworthiness directives that we have seen? So the first one is the rib foot cracks. The other one is the main landing gear fittings gate lip cracks. These are not predominantly known, but these are more of a precautionary measure, in my opinion. I don't know whether how many of the real cracking have actually happened, and the spar ones, which are widespread and kind of much more in the news in the recent times because of the emergency AD that has been issued in the last few days. So the history of this is that the first rib foot cracks that were detected were actually detected during an unscheduled inspection because of the because of um, the incident that happened on one of the A380 Qantas flight, where there was an incident of uncontained engine rotor failure, and that caused some damage to the wing box structure. As a result of that, that flight was grounded and it was inspected, and as a result of that, they found cracks in the rib foot actually, which was not affected by that particular event, but there were cracks in the rib foot. So that is what as was the first starting point of the major inspection of the A380 wings in that sense. So that is what was kind of what called as a type 1 cracks, which are rib to skin panel attachment. And then the type 2 cracks started on the web of the rib fit. And then the remaining cracks followed on later on. So let us see one at a time and see what are the different types of ADs that are issued. So the main purpose of this video is I'm going to summarize all the ADs that have been issued so far and try to give kind of my personal opinion on where we are, and more than the opinion, sorry, the factual information of what is out there from the EASA published website. Unfortunately, we don't have access to any of the service bulletins. We don't know. So we don't know the actual details, or I don't have access to, or I have not seen any of the AOTs, kind of the messages that Airbus sends to the operators to do the inspections and the modifications. All we know is we have the ADs, and within the AD there is some information on what needs to be done. So that's what we're going to look at it today. So the first AD that was inspected or issued was as a result of that uncontained engine rotor failure that I talked about earlier. So which was for a one-time detailed visual inspection of the rib foot for type 1 cracks. So these type 1 cracks are at the rib to skin attachment. So you can say, rib foot to the skin attachment holes here. So that is where the initial cracking was observed. And initially one AD was issued, and subsequently this AD was superseded by another AD, which is given here. And that kind of expanded the inspection from just the rib to skin attachment to include the cracking on the web as well. And these images show the size of the wing box rib here. And the A380 wing box ribs are there are two types of them: fully aluminum, and there are CFRP webs with the metallic rib foot as shown here. I don't know which ones are cracked or what is the details between them, but this is just for the purpose of just to tell you the different types of structures that are there. Then what happened was, then the subsequently that AD also was superseded by another one, where kind of the higher and rather than just one-time inspections, like kind of regular inspections for majority of the fleet. And that particular one is still active, as you can see here. But subsequently, Airbus introduced both the production modifications and in-service modifications, which are addressed by the AD here. So there, the replacement was basically replacing the 7449 alloy material, which was known to have this cracking, with 7010 material. So further details are there, but predominantly the first structural crisis for A380, you could say that it started with the reputation. Then moving on to the next topic is the wing landing gear kind of fitting, not the landing gear itself, but the wing side of the attachment, landing gear to the wing attachment, which is the portion of it is called the gear rib lug. So the pictures shown here are not for A380 actually; they are for they are for A330, because the first AD that was issued was actually to inspect the cracks for the gear rib lugs, based on the experience that was based on the lessons learned from A330 and A340s, where the bush rotation or the pintle, the lug attachment portion, there was a bush and the bush was migrating and the sealant was getting broken, and as a result of that, moisture was getting in, which was leading to corrosion and then subsequent cracking as shown here in the picture. So because the similarity of A330 and A380, so EASA said, okay, there is no reason why the same cracking could not happen on A380. So they said initially they introduced some inspections. But subsequently, that inspection actually revealed some issues, not in the form of cracking, but in the form of kind of sealant broken at those locations. So which means that, there could be a possibility of one of the gear rib cracks. So Airbus developed these repair drawings. Again, the references are from ADs, where to repair the gear rib lug or to replace it, where instructions were provided. And that was again superseded by another AD recently last year, which was kind of gave a tighter compliance times. And also this particular AD also added an additional requirement of the storage return inspections. That means if the aircraft was stored at a particular environment for a prolonged period of time, then what could be the additional inspections that were required there. So this is the AD that is still active now. So if you want, you can go and find out more details about that. Then moving to the current hot topic, I guess the SPAR ones, because recently there was an emergency AD that was issued by AD, and it's all over the news. Even I'm a little surprised by that as well, because there was a previous AD that was issued last year, where to inspect those additional ones, and I don't know why suddenly there has to be an emergency AD. There could have been a normal AD. So the story of this is that the first one was the race spar one. So first known cracking happened on the outer race spar of the A380. So this is at the top and bottom flanges between these two. And again, I don't know the details of what type of crack it is and where the flange or web and all, but all I know is it is specific to this particular material 7449. So then that AD was subsequently updated or superseded by another one, where the outer inner kind of front spar, and then outer kind of the front spar. So these ribs was also added in addition to the outer race spar. So initially the inspection threshold was a 15-year threshold. So they said, after 15 years, you need to start inspecting this. Then Uh, Subsequent AD superseded by another one, where the inspection was reduced from 15 years to 12.5 years for the ORS, whereas for the inner front spar and the middle one, it kept at the same location. So front and rear, it was kept at the same time, which is 15 years. And then subsequently, it had to be reduced even further. So the ORS threshold was reduced from 12.5 to 11.5. So as you can see here, as the investigation progressed from the initial time when as and when they started doing more and more inspections and they found in the aircrafts, and the analysis was getting more progressive, like more understanding the actual mechanism that was going on. So they came up with a reduced threshold uh, between initial and then final one. Then after that, there was, after the COVID storage aircrafts returned to the service, and then they found that that was actually aggravating the situation, or it was having a different impact on the component. So EASA introduced in the next AD a concept called the factor time on ground. So depending upon how much time it is sitting in the ground, you have to account for that in calculating the threshold rather than 15 years or 11.5 years, whatever it is. That terminology was later on again revised, and it was called as a storage factor time on ground. So again, depending upon the different types of environment that was being stored, whether it is hot and humid, or cold, or different storages. We'll see in terms of what is the mechanism actually that drove this in the next slides. So, and then that AD was again subsequently superseded by another AD, which was kind of called for the both the front and rear spars inspections, and this has reduced the threshold from 15 to 13 years for the front spars, whereas it kept the rear spar one at the previous one, which is 11.5 years. So that AD is still active, as you can see here, and then for the rear spars, compliance times and more linked to the storage time earlier. Then coming to the recent ones, which is the mid-spar issue. So all these ADs that I talked about up to this point, they're all targeting the front and rear spars. They were not talking about the mid-spars. But in last year, there was an AD that was issued targeting the mid-spar structure. So it includes all the mid-spar structure between kind of the region, the mid-region basically, which was not inspected earlier. So that was to inspect and then say, okay, where the cracks are going to be found. So my surprise is that this was issued last year, and then they had some time to evaluate all those cracking findings and all, and then based on that, the AD could have been updated or new AD could have been issued to say, yes, here is the revised inspection program. But maybe some sudden cracking has happened, or we don't know the exact reason. EASA has issued an emergency AD. This was like to ground few aircrafts immediately within 2-3 cycles, and then gave, I think, about 10 or 15, 25 cycles actually. So 25 cycles for some other MSN to inspect it very quickly. So that is the kind of the timeline of all the ADs. Then to summarize that, what is the outer spar issues, kind of what do we know of them? So during 2020, during the COVID time, much of the A380 fleet was parked, especially in desert field, in Dubai, Emirates, uh, and for a prolonged period of time, which is 3 years. So hydrogen diffusion happened into the aluminum, which accelerates kind of the environmentally assisted cracking. So the stress corrosion cracking that happens in this particular type of material. Um, I'll give you a reference for one of the EASA safety information bulletin, which was issued much before all these known issues happened on A380 for aircrafts to kind of to give a direction. In fact, I think probably it is worth specifying that service bulletin now. So this is the EASA safety information bulletin that was issued in 2018 to highlight this particular topic actually. So that's what happened, and subsequently led to cracking earlier than anticipated by conventional fatigue analysis methods, because this is a new fatigue cracking mechanism that it was known, but it was not anticipated that this will happen for this material so early. So the aircraft that has not reached the thresholds begins cracking ahead of the schedule. So that is what has prompted the EASA to kind of invent the new metrics that I just talked about, which is the factor time on ground and storage factor time on ground. That weighed to take the weighted average of kind of ground time by environmental conditions rather than simply counting the calendar months. Because if it is environmental assisted cracking, then you assume kind of an average environmental exposure for the aircraft and then calculate particular threshold. But EASA and Airbus kind of came up with this particular terminology of calculating the specific thresholds. So for me, at least, emergency AD is a surprise. So continuing on the kind of the emergency AD, so where exactly we are today is that is a issue, that is a AD that has issued last week, especially focusing on the mid spars. This is obviously it's a primary structural component, uh, which is this emergency AD is a follow on from the previous AD, as I mentioned earlier. So where previously already mid spar cracks were identified after returning from storage for 12 months, and then this emergency AD was triggered after reviewing those results. So a review of 2025 inspection data concluded that the cracks found on certain aeroplanes could reduce the structural integrity of the wing. So Airbus determined that a further special detailed inspection was required urgently. And that is where 5 aircrafts were grounded immediately and 11 aircraft had to be inspected within 25 flight cycles. So now, where we are today, what is the current situation? So, in my opinion, the additional aging aircraft concerns are more additional concerns maybe in the future come, because going by what we have seen in the A380, the fact that very light alloy improvements that made the A380 being lighter and stronger also made it more vulnerable to a failure mode that standard qualifications did not catch, and accumulated hydrogen damage during parking at the rates original fighting models had never anticipated. So my view is maybe there is something that we don't know. So there is an unknown that might kind of come and bite in the future. So this metal fatigue and the hydrogen embrittlement are inseparable and long-term issue in an aluminum structure. So now the new testing and the new way of analyzing the structures has to be in place if the material were to be environmental kind of stress corrosion sensitive or embrittlement sensitive. So parked is not preserved, and the storage at a particular environmental condition accelerates the degradation of the material. We'll see the mechanism in the next slide, which is a theoretical one, and I leave it for you to read that. And importantly, the inspection thresholds must be dynamic. They are not fixed. That means inspection threshold are not just the calendar times, even though if it is an environmental cracking, because in the previous maintenance programs, it was always a calendar time, based on the corrosion program, or it was mainly driven, or it was always aimed at calendar time. Certain after a number of years, you start inspecting it and then have a regular inspection. But in this particular condition, where the stress corrosion cracking has become kind of is environmentally assisted, there the approach of kind of time on ground has become more influential. One important thing is that the system worked. So no A380 has been lost to any structural failure so far, and the early detection through mandatory ADS is exactly what the ICAO and X13 and the proactive safety management systems are designed to achieve. And in that way, I think the safety management system and the emergency ADs that the EASA issues, and the proactive inspection regime that Airbus gives to the operators and all, these are all commendable. And that is what we see, even though there is an disruption to the service and all, but safety has been maintained in that sense. And further ADs are likely, obviously, following this emergency AD. So there will be some findings, and then we can expect to EASA to issue another airworthiness directive soon. So the last slide in this video is what I'm going to kind of talk about or summarize here is the summary of the hydrogen environmentally assisted cracking. Because here is a theory that you can pause the video and you can go through the theory, or you can refer to the service bulletin or safety information bulletin, sorry, which was issued much earlier than all these known crackings of the A380. So one of the main problem was the material. So that material was very sensitive to this type of cracking, and it was not anticipated at the time of design, and hence it was selected that for the weight saving purpose. But these additional fatigue failure mechanisms have thrown up. So that's all I wanted to summarize, and thank you for watching, and hope you like the video, and keep in touch with our channels.